So, now we have to see resolution of vector in 3 dimension. So, here resolution of vector in 3 dimension. Suppose you have taken x, y and z axis. Now, let us complete first diagram. This is x axis, this is y axis, this is z axis, this is the point O. There is a vector A like this. This vector A is making an angle alpha with the x axis. This is making an angle beta with the y axis, and this is making an angle gamma with the z axis. So, this symbol is of gamma, that is with the z axis. Now, here we can write vector A is equal to Ax I cap plus Ay j cap plus Az k cap. So, this vector is here Ax, here this is Ay and this is here Az. Now, if you want to get magnitude of these, you will be getting under root of Ax square plus Ay square plus Az square. Now, see here, also we can take one interesting formula here you can get from here. We can write here simply Ax is equal to A cos alpha, Ay is equal to A sin alpha, A cos beta, and Az is equal to A cos gamma. If you put here all these values, what will you be getting? You will be getting A is equal to under root of A square cos square alpha plus A square cos square beta plus A square cos square gamma. Take A common and just solve it. Ultimately, you will be getting here cos square alpha plus cos square beta plus cos square gamma is equal to 1. It means square of cosine of all angles, sum of the square of cosine of angle alpha, beta and gamma is equal to unity, that is equal to 1. So, this was the resolution of vector into 3 dimension. But see here, resolution of vector for a given vector is actually a unique. It has got a unique component for the given vector. This we can also justify by taking an example, uniqueness of the resolution of vector. Suppose you have got vector A, this is vector R. You can take two components, one this side vector A and one this side, this is vector B. Let certain real numbers here m and n, so we can write here R is equal to vector m A plus n B. So, we say this is actually unique. It means its components whatever we divide they are unique, uniqueness of the resolution of vector. We can prove by this way. We just take another assumption. Suppose there are two other real numbers m dash and n dash. Then we can write R vector is equal to m dash A plus n dash B. But these two, this and this are equal, these two. So, what you can write? M A plus N B is equal to m dash A plus n dash B. Now, we can write here m minus m dash vector A is equal to n dash minus n, that is vector B. This is only possible if you are taking m minus m dash equal to 0 and n dash minus n equal to 0. It means m is equal to m dash and n is equal to n dash. What does it mean? It means this explains actually uniqueness of the resolution of vector. So, whatever the two components of a given vector you get, they are actually unique components. So, these things are about the resolution of vectors.